Okay, welcome back. Hopefully you've taken the time to look at the game class and the room class and realize that there's some serious problems there, even though everything works. So I'm going to open up the code editor. And here we have the game class doing its job. And I'm also going to open up the room class, which is doing its job. And let me see if I am able to move this tab. Oh, that's not exactly how I wanted it to work, but it'll have to do. There are no problems, just happy accidents. Okay, that was a happy accident too. I'd have no idea how Bob Ross just kept such an even keel. Game class, room class. We do need to see both of them mostly side by side here. And since I'm not maximizing my desktop, I can't use the operating system to do the easy dock to each side of the window trick. So we have the game class. It has two fields, a parser object and a room object, and the game doesn't know the entire network of possibilities. It just knows the room that you are currently in. And then we also have this create rooms method, which makes a bunch of room objects. So when we construct a game, it needs to create rooms and start up the new parser. And when we call create rooms, we have 5 room objects. And we start by calling the constructor for the room, where we pass in a string, which is the description that the player gets to see. So the variable outside gets the description outside the main entrance of the university, and so on down the list. And then, after the rooms have been created, we need to stitch these rooms together. If we look at the room object, every room has a string field, which is its own description, and then a room also has 4 room objects describing which room, or a reference to which room is at its north, which room is at its south, which room is at its east, which room is at its west. When we have a room created, we just give it the description. And then we also create, with set exits, we tell the room what's the room reference at your north, east, south, and west. So we go around in a clockwise way from 12 o'clock north to 3 o'clock to east to 6 o'clock to south to 9 o'clock to west to set the exits. And we pass those values in, and if there is a reference, we set it, and if there's not, we don't. And remember that objects, when they are declared by default, are initialized to null. So a room will have a null stored if we don't pass a null in. So if we look when we call outside set exits, That's telling us that there is no room to the north, the theater is to the east, the lab is to the south, the pub is to the west. And so outside now has a reference to these other objects. And then we do likewise for the theater, null, null, null outside, pub, null outside, null, null. You see how this works. So if there is a room that it's connected to, we are connecting in that way. It's a little kludgy, but it works. So why is this so bad? Well, let's come down and look at what happens later on. I'm going to also look. The only other method inside of the room class, apart from setting its exits, is returning its own description. So it's just going to give us a string that says this is what you see when you're in this room. So I'm going to bring the game class back over. When we select play, internal method call, print welcome. Then we enter this block of code, pre-loop condition, set finished equal to false. While we are not finished, so if finished is false, not finished is true, tell the parser to get a command and put it into the command object, and then we will process that command, and process command will turn back true if we were told to quit, or false at any other time, and we will stay in the loop. So process command is going to have to do some heavy lifting. But let's look at what print welcome needs to do. To get the game going, we need to print out the introduction and some instructions. We need to ask the current room to give us its description. And then we need to ask that current room, if your north exit's not null, then we should print out north. If your east exit is not null, we should print out east. And notice there's a space after that, so it doesn't come slammed together. If the current room south exit's not null, print out south, and if the current room's west exit's not null, print out west, and then a new print line. So notice these are prints rather than print lines, so they don't go down. They just keep staying on the same line. So one problem here is that current room is accessing, which is a room object, is accessing the north exit field. Whoops, I did not mean to scroll up. I was trying to change my north exit, while it's a field, is public, which means that game can go in and look at that directly. And not only read it, but also write it if we wanted to. But we're writing this block of code over here because the room doesn't give us this information, but it gives us access to this information. So we end up writing some code inside of game that handles a task that must be done. But this is just inside print welcome. Look what happens inside of process command. We are going to return a Boolean, and so we're going to keep track of that. If the command is unknown, we didn't try to quit because we didn't recognize it as quit. We just get out early. There's no point in knowing what's happening. So this is by using tests against the command words. But if it is a command we know, we ask the command to give us the command word, and then if we recognize it, if it's help, we'll print help. If it's go, we'll run this go room command. And if it's quit, we will use the pass the command word to quit and get back want to quit from that. And then eventually we return either false or true. Okay, if we're trying to go to another room, if we just say go and we don't give another direction, it's going to print out go where and get out early because it doesn't know where we're supposed to go. Otherwise, so if the command doesn't have a second word, we do that. If it does have a second word, read the second word, put it in the variable direction, and then, oh, look at this. If that direction equals north, we need to change our current room. Our next room becomes the room's north exit. So hold on, because we need to indicate that we're moving without moving yet. Okay, so we'll set next room. And if it's not this one, we'll set next room here. And if it's not that one, we'll set next room here. And if it's not this one, we'll set next room here. Then, if next room is still null, remember that null indicates that there was no room to go to. We'll print out there's no door. But if it's not null, then our variable of where we are becomes the value of what the next room object is. And then we need to print out, okay, you are in, this is now your current room because the current room has changed. And then we'll also need to go through and print out all of this information. Again, it's repeating code. This is the exact same code that was in print welcome. Game is doing way too much work here. It's doing work that it shouldn't need to do, that it's not its responsibility to do. So let's talk about that in terms of the phrases or the terms coupling and cohesion. Yes, Zulbad works, but we need language to describe why just because it works it's not good enough. So our metrics for assessment are going to be how tightly coupled the code is and how cohesive the code is. So let's define what we mean by these. I'm going to begin by saying it's not possible to completely decouple code. If code doesn't share some form of information, then you don't have a system, you have two discrete items. But there are different ways to choose the degree of which coupling you're going to end up with. And so what we look for is that while code has to share information, can we share that information in a way that minimizes the amount of work that needs to be done should a change be desired? If classes know each other's internal details intimately, if objects don't pass information through methods, or if fields are public instead of private, we say that these objects are tightly coupled. What we really want is we want objects to be loosely coupled. Now, our class diagram would indicate where coupling could exist, because coupling is going to exist wherever you see that an object depends on another object. So that's a good measure of where we can look for problems to exist. Looking at cohesion, cohesion refers to the number and diversity of tasks that a unit of code is responsible for. A class should be responsible for one object. Not one instance, but one concept, one conceptual object. A method should be responsible for doing one discrete task. If a method does two tasks, you should probably break that method out into two separate methods. Or alternately, if a method always does one task and sometimes does another task, and sometimes you call the method to get the sometimes behavior, that's called a side effect. And if you have a side effect, it could lead to um, very pernicious bugs that are hard to find. Okay, so we want loose coupling and we want high cohesion, where a package is a grouping of reasonable collection of classes, or a class models one discrete, well-defined entity, or that methods perform one clearly defined task. So to see where we run into problems, especially with coupling, what happened when you tried to add the command words up and down, the new directions? How much of the code had to change? And if you did do it, how certain are you that it worked completely? Like you had strong confidence that you were able to put it in all of the places it needed to go. Did you remember that it needed to be in Go Room in order to indicate the test that you could go that way? And also in the lower portion where you had to print out the exits? Maybe you put it in Go Room, but did you also remember that it needed to be up here inside of Print Welcome? Because you need to add the possibility that the opening room could also have up and down? This tight coupling and honestly poor cohesion of what Print Welcome's job is and what Go Room's job is a problem. It creates a maintenance headache. And also, we started with 4 directions and then we went to 6. But what happens if you add northeast and southeast and northwest and southwest? What happens to these blocks of code? What happens to your maintenance pattern? It's a very, very difficult system to extend right now. So if you've tried to add up and down, you can see that it would be beneficial if there was some way for us to loosen the coupling between these two classes, between game and room. What we want, what loose coupling gives us, is this ability to understand one class without having to know how another class works. In order to make the change to game, you also needed to make changes to room, didn't you? You had to add new directions there, and you had to change the constructor, and you had to change the constructor in room, and then you had to change the call to the constructor in game. And all of those things just keep cascading. Loose coupling makes it easier to understand a class without needing to get into the source code of others. And the advantage also to loose coupling is that we can make a change to a class, and all we have to worry about is tweaking the interface, the code interface, so that the class that is, the client class that is asking the responding class or server class for information knows what to ask for and what it can expect back. So depending on the nature of the change, it might not need any modification to another class, or hopefully only a slight modification. As a result, writing with loose coupling increases maintainability. Now, we now have language to use to describe the problem in Zulbad, which is to say that there is very tight coupling between game and room. Changes to the room class bring in a cascade of changes that have to occur inside of the game class. And then you're left with other questions if you didn't update your documentation. Is the constructor call first up, then down, then north, east, south, west, or was it up, north, east, south, down, west? And that sounds trivial, but it changes the nature of, changes the actual structure of the map. So it's actually very important to have this lockdown. If things are tightly coupled, you have to understand multiple classes in order to understand the scope of what that grouping is being used to, how that grouping is being used to solve a problem. And then the flow of control between the objects that are passed back and forth between the classes must also be understood um, and explained and documented. And that makes the entire process more complex as well. When we come back, let's look at a more loosely coupled version called Zool Better.